Hello my dear student. This is my next video for the chapter 12 electricity, and this is the second part of the numericals. So before starting the numerical, read this quote. Success doesn't come to you. You go to it. What does it mean? You have to try again and again until you will get a success in your life. Now see this before starting the topic. Please do like and subscribe my channel and press the bell icon button for further notification, and do write your name, class, section, roll number in the comment box. So let's continue for the topic. This is our next question on page number 221, question number 12. Several of electric lamps designed to be used on 220 volt electric supply are rated 10 watt each. Calculate the number of lamps that can be connected in parallel to each other across the two wires of 220 volt line if the maximum allowable current is 5 ampere. So what you have understood by the given statement? V means potential difference is given 220 volt, power of each bulb is given 10 watt, and when they are connected in parallel with each other, total current they withdraw in the circuit is 5 ampere. So using power formula P is equal to V square by R, we will calculate the resistance of each bulb. That is V square by P will come. So R value 220 into 220 over power of each bulb. So we will get it 4840 ohm. This is the resistance of each bulb. Now these bulbs with this resistance are connected in parallel. How many bulbs are connected we don't know, and they are connected in parallel. So let n is the number of lamps are connected in parallel, each of resistance R. We have to calculate that. Or here R value is given. We have calculated 4840 ohm. So 1 upon R dash is 1 upon R up to n terms. So 1 by R is n into 1 by R. So from here we will get R dash, that is resistance in parallel, is equal to R by n. What is the R value we have just now calculated? 4840 by n. Now we have to calculate the number of resistors. So we know that total potential is total current into total resistance. So, but we are not having this value. We are having this value in terms of R by n. So we will substitute it 220 into 5 into this value. So from here we will calculate n. Cross multiply do, and then you will able to solve this value. 5 into 4840 upon 220. That is 110. So 110 lamps are connected in parallel when their value is 4840 ohm, and after that only we can withdraw the current of 5 ampere. Same type of already a numerical number 10 you have done in your NCRT, but their direct resistance was given, but in this question power was given. This is only the difference in the question. Otherwise these two questions are same. So let's do now next question. This is next question number 13 on page 221. Now see this, a hot plate of electric oven connected to 220 volt line has two resistance coil. How many coils? Two, A and B. Each of resistance 24 ohm, means coil A is also having resistance 24, B is also having resistance 24, which may be used separately, in series, in parallel. Means three types we have to do this question. Individually we have to use them, series combination we have to use them, in parallel we have to use them. What are the currents in each three cases? So let us do that. When used individually, let's first do this. Individually means R1 is 24, R2 is 24. What is the total potential given? 220 volt line. By Ohm's law, V is equal to IR. I is equal to V by R. So I is equal to 220 potential upon 24 ohm. We will get the current value 9.16 ampere. Both will draw each 9.16 ampere. Now let's combine them in series. When we will combine R1 and R2 in series, we will use the formula RS. RS is equal to R1 plus R2. That is A and B here given. So 24 plus 24, 48 ohm. Again by Ohm's law, current formula is V upon RS. Why RS? Because this time combination is in series, this time individual, this time in series. So 220 upon 48. So what the value of the current you will get? 4.58. Now third case, when we use these two coil in parallel combination with each other. So we will find out total resistance in parallel first. 1 by Rp is 1 by 24, 1 by 24. 24 LCM, 1 plus 1, 2. So what is the Rp value you will get? 12 ohm. Again use the Ohm's law. V is equal to Ip into Rp. So what is the current in parallel? V by Rp. Put the value 220 upon 12. 18.3 ampere. So what you are observing, when we are using the coils in parallel combination, then maximum current is flowing, and when we are using them in series combination, then minimum current is flowing. So in this way you have to do this numerical. Now let's do the next numerical. See student, this is question 14 on page number 221. What is the question? Compare the power used in 2 ohm resistor only in each of the following circuit. Circuit means we are having combination of different resistors. First is 6 volt battery in series with 1 ohm and 2 ohm. How many resistors given? 1 ohm and 2 ohm. And how they are connected in series? So 1 ohm and 2 ohm is connected in series, and what is the potential? 6 volt. So as you know that total potential is given, we will find out total resistance. So what is the total resistance? 1 plus 2, 3 ohm. So using Ohm's law, we will use the formula V is equal to IRS. So from here we will calculate I, V by RS. So that is 6 by 3 because potential is 6 volt given. So we have got current value 2 ampere. As you know that in series, current through each resistor and through the circuit remains same. So we will use this current in the power formula because we have to calculate power of this 2 ohm resistor. So what is power formula? Power is I square into R. When series combination we are having. So 2 square into 2, you will get your answer 8 watt. Now see the second part. When 4 volt battery is connected in parallel with 12 ohm and 2 ohm resistor. See this now, resistors also change. One is 2 ohm and one is 12 ohm. And how they are connected? They are connected with the battery 4 volt. But this time not in series, they are connected in parallel. And you know that in parallel circuit, voltage is same across each resistor and through the circuit also. So direct here 4 volt potential is given and they are in parallel. So we can use the power formula V square by R, that is 4 square by 2. So when you will solve it, you will get your answer 8 watt. So this 2 ohm is having here also power 8 watt, here also power 8 watt, but their combination is different. So now what is the ratio? P1 is to P2. 8 upon 8, that is 1 is to 1. So we will get the ratio of the power is 1 is to 1. Now let's do the next question. Question number 15 of your NCRT. See this is the question 15 on page 221. 2 lamps, one rated 100 watt power at 220 volt connected and another of 60 watt power, the same potential it is connected in parallel to the electric main supply. Means they both bulb are connected in parallel with each other. What current is drawn from the line if the supply voltage is 220 volt? Now this question shows that potential remains same when they are connected in parallel with each other. So as you know that, let's see it, we have to check what is the total current withdrawn by them when they are in parallel combination. So what is the power you are watching of the first bulb? 100 watt. Voltage 220 volt. Resistance of bulb we don't know. Current withdrawn by the bulb also we don't know. But how we can calculate? Check it. Power P1 is V square by R1. So from here we will calculate resistance of the first bulb. That is 484 ohm. You will calculate by this formula. Now by Ohm's law, V is equal to I1 R1. V is given 220 volt. So we have calculated V upon R1 220 upon 484. That is the current drawn also by the first bulb is 0.45 ampere. Similarly, for second bulb of power 60 watt, potential 220 volt, resistance again not given of the bulb and current is also not given. So we will find out the resistance of the bulb by the formula V square upon R. So what is the resistance of the second bulb? V square by power 220 upon 60. Its square is there upon 60. So you will get the resistance of this 60 watt bulb is 806.6 ohm. Again use Ohm's law to calculate the current here. I2 is V by R2. So 220 upon this value 806.6 ohm. You will get the current I2 is 0.27 ampere. Now see, this is the individual current drawn by the bulbs. But you know that in parallel, total current is calculated by I1 plus I2 formula. So we will add these two current 0.45 plus 0.27 ampere is equal to 0.72 ampere. There is one more alternative method is also there. If anywhere you want to try to solve that also, you can find out resistance and then you can combine these two resistance in parallel with each other, find out total resistance, and then with that potential also you can do that method also. But this is the easy one method and short also. So in this way you have to do the numerical. Now let's do another numerical, question number 16. See this question number 16 now. Which uses the more energy? A 250-watt TV set in 1 hour or 1200-watt toaster in 10 minutes? Very simple question. This is energy consumed by TV set in 1 hour. First we calculate. What is the formula for energy? Power into time. That is 250 into 1 hour, because power of what TV is given 250 watt. And how much time it is working? 1 hour. So it becomes 250 watt hour. You can divide by 1000 also and you can calculate your answer in kilowatt hour also. But this is also okay here. Second is energy consumed by toaster in 10 minutes. What is the power of toaster? 1200 watt. What is the time? 10 minutes. So we will use here again energy is power into time. But time should be in hour. So we divide by 16. So when will you solve it? You will get your answer 200 watt hour. Again here you can calculate in kilowatt hour by dividing by 1000. Simply you can compare that. TV consumed 250 watt hour and it consumed 200 watt hour. So who is consuming more energy? So we will say that TV set is consuming more energy. Now see this next question. Question number 17. An electric heater of resistance 8 ohm drawn 15 ampere current from the service mains 2 hours when it is working. Calculate the rate at which heat is developed in the heater. What we have to calculate? Rate at which heat developed. Means heat energy upon time. What is the resistance? 8 ohm. What is the current? 15 ampere. For how much it is working? For how much time it is working? 2 hours. So rate of heat developed is heat energy upon time. So what is the heat energy formula? I square R into T. T is a T cancel out with T each other. What is the current value? 15. What is the time value? Resistance value? 8. So when will you solve it? You will get your answer 1800 joule per second. You can do in another way also. Ki first you calculate heat and in next step divide by time. Then also you will get the same answer. So this is all about 16 and 17 question. Let's do one numerical left in between where we have to do the combination of the resistors. So let's do that question. Say this question now we have left in between because in this we have to do some combination. That's why it is left. Now let us see this question. Question number 11 on page 221. Show how you would connect 3 resistors, each of 6 ohm. What does it mean? R1, R2, R3. They are of same value, that is 6 ohm. So that combination has a resistance of 9 ohm and 4 ohm. Means you have to combine these 3 resistors in such a way that first you will get 9 ohm and then connect in different ways so that you will get a 4 ohm. You know that 2 combination already we have done in series or in parallel. But here we have to do in different way. So this is called series parallel combination. Now to get a 9 ohm, we will do this combination first. 6 ohm, 2 6 ohm resistors in parallel and with that combination in series with the first one. Now see this 6 ohm and 6 ohm we have connected in parallel. So see this 1 by RP is 1 by 6 plus 1 by 6. You will solve it 3 ohm. Now this 3 ohm, this total is in series with the first. So you will get by this combination total resistance 9 ohm. Now to get a 4 ohm, first connect 2 resistors in series and their total with parallel with third one. Now see this, when we will connect 2 resistors in series, 6 plus 6 you will get 12 ohm. Now this combination is with this third one in parallel. 1 by 12 plus 1 by 6, that is a 12 ohm. LCM you will take and when you will solve it you will get your answer 4 ohm. In these questions you have to check the combination by yourself where you have to increase the value. First do parallel and then do series, and where you have to decrease the value, first do series then do the parallel. In this way you are able to solve this type of question. Thank you. Have a nice day and try these questions.